point, just message. Okay. Okay. We can start. So write down the questions. Write down the next question. Define optical center of a spherical lens. Define optical center of a spherical lens. This is first bit from this question. Then write down second bit. A divergent lens has a focal length of 20 centimeter. A divergent lens of focal length 20 centimeter. Advait, are you there? Full stop. At what distance? At what distance should an object of height 4 centimeter? Hi Anya. Okay. Height 4 centimeter from the optical center. From the optical center of the lens be placed so that its image is formed 10 centimeter away from the lens, full stop. Find the size of the image also. Find the size of the image also. Full stop. Third bit from this question. Draw a ray diagram to show the formation of image in the above situation. Draw a ray diagram to show the formation of image in the above situation. So I will read the question one more time. Define optical center of a spherical lens. B. A divergent lens has a focal length of 20 centimeter. At what distance should an object of height 4 centimeter from the optical center of the lens be placed so that its image is formed 10 centimeter away from the lens? Find the size of the image also. And last bit, draw the ray diagram to show the formation of image in the above situation. Okay. In the last session, we did the many problems on concave lens. Okay. Here first they are asking optical center of the spherical lens. We know that if you take any concave or convex lens, there is what optical center, and that optical center we are representing by O. Okay. Optical center is what? A spherical lens. The center, optical center of a spherical lens is defined as a point which is on the principal axis through which the light ray from undeviated. That is called as what? The optical center. If you take this concave lens or here, this is what we have, the convex lens or here. Okay, so I will show you. This is the convex lens. So this is a line which is passing through this lens. Okay, so this is nothing but what? Your principal axis, and this is what? Your optical center. So the ray which is traveling from the object, which is passing through this center, optical center, it is what gets, it is not refracted, so it is get retraces on the same path. Okay, so that point is called as what? Optical center over here. This is the answer of first bit. If you take concave, convex, the optical center is at the it is a point where the ray of light which is not deviated. Okay, it retraces back the same path. That is called as what? Here the optical center. Now here they are saying divergent lens. So in the last session I told you divergent lens is nothing but what? Your concave lens, okay, and converging lens is nothing but what? Your convex lens. Okay, it's very important. So this is nothing but what? Your convex lens, and this convex lens is also known as what? Converging lens. Okay, and this is nothing but what? Your concave lens, and concave lens, and it is also known as what? Divergent lens also. Okay, so this is what the first bit we did. Then second bit they are asking divergent lens. Divergent lens means the given lens is concave lens. Both the names you should know. So in concave lens I told you focal length is negative, u is negative. Okay, so now can you find out the distances which are given here? The divergent ray has a focal length 20, directly given. F is given minus 20 centimeter. Focal length for the concave lens is always negative. I told you in the last session. Okay. Then optical. Then they are saying at what distance should an object of height 4 centimeter. That means here HO. Object height is given plus 4 centimeter. It is above the principal axis. From the optical center of the lens be placed so that its image is formed 10 centimeter away from the lens. Okay, so 10 centimeter away from the lens image is formed, that means V, and in case of concave image is formed on the same side of the lens, so here V is given minus 10. Okay, so I told you how to take the distances. Okay, that is I already explained you in the previous session. Okay, so how to in concave lens U, V and F, mostly we got all negative. Focal length is always negative in concave lens. Okay, so this is what given. From that you have to find out the distance for U and you have to find out the HI, okay, height of the image. So I will give you 2 minutes, find out the answer. I will give you 2 minutes, use a lens formula and find out. Yes, you got the answer. Use the lens formula here. Check. Just type your answer for U. U, how much you got? What is the value for U here? length is given. So use the length formula. 1 by f is equal to 1 by v minus 1 by u. So we have to find out here u. So take 1 by u to this side, this will become positive. 1 by v and focal length you can transpose here. So it will become minus 1 by f. So v is given minus 1 by 10 and focal length is also minus of 1 by 20. So minus minus will become plus, minus 1 by 10 plus 1 by 20, and if you take a LCM here, this will become minus 2 plus 1 by 20, that is nothing but minus 1 by 20. So here you will get it as a minus 20 centimeter. Okay. So concave के लिए I told you in the last session, those who are not there in the for last session, they can check the link afterwards. Okay. So here in case of concave, focal is always negative, v is negative, and u we are getting what here negative. So here we got u. Once we get the u, they are asking us to find out the size of the image also. Okay, size of the image we have to find out. So we know that magnification m. Okay, so magnification m in case of lens, m is equal to v by u is nothing but hi by ho. Okay, ho is given and we are interested in finding out hi. Okay, so here we can write hi is nothing but v by u into what ho. Multiply this, take a cross multiplication here. So here we have a minus 10, u we got it as minus 20, and ho is nothing but 4 given. So minus minus get cancelled and 2 ones are 2, 2 2s are 4. So hi I am getting it as a 2 centimeter, which is positive. Okay, so this is what the answer. And then second bit, they are not asking here nature and all. So this simply they are asking height of the object, height of the image, and u they are asking, and both the things we got. Okay, second bit finished. Now go for the next last point, that is a ray diagram. Okay, for this given situation we have to draw the ray diagram. Okay, so can you find out here ray diagram? Dekho, one more thing you can remember here, don't forget ho, object is 4 and image, I am getting image height is 2. That means it is a diminished image. Okay, this is nothing but what? Diminished. Okay, now we have to draw the ray diagram. So I erase this calculation part and rest value I will keep it as it is for my reference to draw the ray diagram. Okay, first this is a divergent lens, that means this is the concave. Okay, draw this lens first. Okay, try to grab one mark. Okay, so here we have a optical center. This is f1 and this is twice of f1. Okay, focal length is minus 20. That means this focal is nothing but what? Minus 20 centimeter, and this is f we have. Then u, I got it as a minus 20. That means my object is on the focus. Okay, my object is on the focus. Focal length is also minus 20, u is also minus 20. So suppose I will take this as a and b. Now first ray which is traveling parallel to this principal axis, so it is appear to focus at point f1, but it is what gets diverted. Okay, there is a divergence. So this is what the first. Then second ray of light is passing through the optical center. See, second ray of light is passing through the optical center. Okay, and we know that the ray which is passing through the optical center, it is what retraces back on the same path. Okay, there is a no refraction will takes place over here, and where these both rays are intersecting, from that point you can drop a perpendicular on the principal axis. This you will get it as a dash and this as what? B dash. So I kept the values as it is here. So here HO is 4. So this HO is 4 here, and image I got 2 centimeters. So A dash B dash I got 2 also. Means what? As compared to the object height with this image, so image is what? Image height is get reduced. So from this also we are getting reduced height, which is shown with red color. Okay, so this is what the answer, and we verified red with a red diagram also. Okay, so this is what your answer. So here these are the three answers for the three given bits. Can you getting? Hriday, are you there? Advait, are you there? Those who are joined, they can able to understand. Others are also can reply. Those who are joined, they can also reply is they are getting this session, the questions which we are taking. Write down one more question next. Okay, next question you can write down. Define the focal length of the divergent lens. Define the focal length of the divergent lens. Second bit, a divergent lens of focal length 30 cm. Second bit, write down a divergent lens of focal length. A divergent lens of a focal length 30 cm forms the image of an object of size 6 centimeter on the same size 6 centimeter on the same side as the object at a distance of at a distance of 15 centimeter from its optical center, full stop. Use the lens formula to determine the distance of the object. Used to determine the distance of the object from the lens and the size of the image formed. Full stop. Last bit, draw the ray diagram. Draw the ray diagram to show the formation of the image in the above situation. image in the above situation. I will repeat this question. Define the focal length of the divergent lens. Second, a divergent lens of focal length 30 cm forms the image of an object of size 6 cm on the same side as the object of distance of 15 cm from its optical center. Use lens formula to determine the distance of the object from the lens and the size of the image formed. Okay, and last bit, that is draw the ray diagram to show the formation of the image in the above situation. Okay, so we already did many problems on this, so try to find out and Advait will tell the answer. I will give you 1 minute. हो गया? Advait got the answer? Yes, who all get the answer? What is the focal length here? Focal length is given here minus 30. U we have to find out. V is given here minus 15 centimeter. H1 is given plus 6 centimeter and we have to find out the image height over here. Okay, we did many problems on this, but still I will solve for you. After this I am taking some different types of questions. Okay. So here focal length for this, in this case, is given, I think, yeah, focal length is minus 30. Okay, height of the object is given 6 centimeter. Then V, in this case it is given minus 15 centimeter. Okay, and we have to find out here U. Okay, so use here lens formula. Okay, we have to use lens formula. What is our lens formula? Always write the formula first and then rearrange. Okay, so here we have to find out U. So I will take U to this side, 1 by V minus 1 by F. V is nothing but minus 1 by 15 minus focal length is nothing but minus 30, 1 by 30. Okay, so minus 1 by 15 minus plus 1 by 30. So here take LCM, minus 2 plus 1 by 30, that is equal to minus 1 by 30. This is nothing but U. U is nothing but minus 30 centimeter. So U, once you get the U, they are asking us to find out the HI. So we know that in case of lens, U by V, magnification U by V is equal to, we are writing HI by HO. Okay, HI I have to find out. So U by V into H naught. So U I have here minus 30 and this is what, minus 15 into, or not minus 15, yeah, V is minus 15, sorry, V is minus 15, this is minus 30, HO I have 6. So here 6 ones are 6, 6 5s are 30, minus get cancelled, 5 3s are 15. So HI I will get it as a 3 centimeter. Okay, so this is nothing but what, the answer. Okay, ray diagram we have to find out. So can you now able to find out the ray diagram? We have here again divergent lens, that means concave lens. Okay, so here I will draw again. is the principal axis, optical center f1, and this is twice of f1. So here focal length, this focal length is 30. Okay, and V I got it as somewhere 50, V somewhere here, but I am interested in U. U is minus 30. Okay, focal length is this, that means U is kept on the focus only. Okay, so again this ray of light is first ray of light traveling parallelly, then it is passing, it is appeared at the focus and then it is get diverted, and then another ray of light is passing through the focus optical center, then it is retraces back on the same path. Where they both are meeting, from that you can drop a perpendicular, so you will get the answer over here. Okay, suppose this is AB, then this you will get it as a dash B dash. That's it. This is the 3-mark problem. Okay, show the rays properly. We did many problems. Those who want basic for this, you can check for the previous video. Okay, copy this or take a screenshot. What Advait know? Okay, write down next question. A beam of light are incident. Write down next question. A beam of light or a beams of a light are incident. Beams of light are incident through the holes A and B. A and B, and emerges out of the box. Emerges out of the box through the holes C and D. Through the holes C and D respectively. C and D respectively, as shown in figure. As shown in figure, full stop. Which of the following could be inside the box? Which of the following could be inside the box? Okay, write down the options. First is a rectangular glass slab. First is a rectangular glass slab. First is a rectangular glass slab. Second bit, convex lens. Convex lens. Then next bit, next option, concave lens. Concave lens. Okay, then last option, that is prism. Okay, last option is prism, and draw this diagram. This is the diagram given in the question. Okay, so the light entering into this is AB and this is CD. Okay, draw the diagram. Okay, and this is what the box they gave. Okay, so I will repeat this question. Check the arrows. Okay, to A and B light is entering, and through C and D light is what going out. Okay, so here beams of a light are incident through the holes A and B and emerges out of the box through the holes C and D. As shown in figure, which of the following could be inside the box? Rectangular glass slab, convex lens, concave lens, and prism. Okay, everyone copied this question. very important question for an exam point of view. Maybe they will change the situation here. The concept is very important. Okay, so if you observe this one, this box, okay, here from A and B light is entering and C and D light is coming out. Okay, this is first observation. What should be the second observation? See, the light which is entering into this box and the light which is emerging out from the box, both are parallel, no? They are going in the same direction, and moreover there is a no refraction, reflection, but the lines are what? Parallel with each other. This is the second option, second observation. Now what is the concept? Okay, which concept is clicking now in your mind? If you studied, then you will get this concept. Actually we did one experiment, that is yesterday we did one rectangular slab experiment. Okay, so whenever here we have a air as a medium and another is a denser medium, rarer and denser medium we have, and whenever the incident ray traveling from air to denser, so from here we are drawing normal. Now this refracted ray, the ray is what get refracted when it enters into the second medium apart from the rarer. So it is what gets refracted into this glass slab, and again when it hits from that point, it is what emerges out, and while leaving from denser to rarer, it is going away from the normal. This we did. Okay, suppose if there is a no medium, then in that case the ray of light should what? Without any deflection, it can travel in the same direction. So in that case, so this refracted ray and this, if there is a no material, both are what? Parallel. So that concept I have to apply. That is a rectangular glass slab should be there inside this box. Okay, that is the reason the rays are what? Can you able to see? Parallel. So that's what here, here also rays are parallel. So here answer is your first bit, that is a rectangular glass slab. Can you getting this? समझ में आ रहा है question? So here option you have to choose, that is first rectangular glass slab. Okay, don't think this ABCD, that box is a rectangular, that's what I took rectangular. No, this is not like that. Okay, so here we are applying rectangular ray of the lateral shift distance. Okay, or we are taking the rays in a parallel, what we can say, that the glass slab, that concept we are using. So you can right tick the answer first one. Getting this, Advait? Advait getting? Hriday, are you there? Now you are sleeping turn by turn. I will check your notebooks also, once you comes here. Write down next question. A beam of light is incident. A beam of light incident through the holes on side A, through the holes on side A, and emerges out of the hole, and emerges out of the hole on the other face, on the other face of the box, on the other face of the box as shown in figure, as shown in figure. Which of the following could be inside the box? Which of the following could be inside the box? Okay, I'll repeat. A beam of light is incident through the holes on side A and emerges out of the hole on the other face of the box as shown in figure, full stop, which of the following could be inside the box? Okay, question mark, write down the options. First is a concave lens, concave lens. Second, rectangular glass slab, rectangular glass slab, rectangular glass slab. Second, third option, prism, prism, and last, convex lens. And last is the convex lens. And here diagram is given. Draw the diagram. Okay, draw the diagram here. Total 10 lines are there. Total 10 lines are there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And these rays are entering into this given box. This box, they can write it, these points as A and B, and the ray of light which is coming from this side and 10. Okay, so here 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. The ray of light coming out. Okay, so this is what the given diagram. Okay, here again observation is very important. Okay, you people are always in rush, you know, you people are scientist people, you know everything. Okay, that's what, you are not observing the question, diagram, nothing properly. So you can start developing that vision. So here the box is given and here ray of light are entering into this box. Okay, so answer, what should be the answer? Okay, so observe what you are observing here. What should be a possibility here? देखो, first you can check. These 1 to 10 rays are entering from face A and 1 to 10 rays are emerges out from point B. Okay, but while emerging out, they are emerging from the same point. Okay, and we are wrote the numbering is increasing from bottom to top. Okay, and if you take here the bottom number means top number 10, we come to here. Okay, so this case is only possible in the convex lens. Okay, because if we take the convex lens, suppose the object is kept at a certain distances, so the number of rays are what, traveling parallel. Okay, and if there is a focus F, then this ray of light is passing through the focus. Suppose this is my first line, so first will come here, then another ray of light is nothing but what, passing through this focus. So this is nothing but what, your second. Okay, so here what, 1 will come here, 2 will go down. So 10 is comes here, 9 will come here. So this focused at one point. They are what, in convex lens they are converging. Okay, and they are remaining are what, coming out. So they are having one converging point. So here we have a converging point. So that's what, this is nothing but convex lens. Maybe this is what, convex lens. So answer is, I think, which option is there? Yeah, this answer is convex lens. Option D is the correct option. Always remember, observe the diagrams properly, check the rays in this chapter properly. Okay, if you know the concept clearly, clear concept if you have for this chapter, then you can able to attempt the MCQs properly. Getting this? समझ में आ रहा है सबको? Okay, चलो next question, write down. Take a screenshot. Write down. Next question. The path of ray of light coming from air passing through a rectangular glass slab traced by four students as shown in figure A, B, C and D. A, B, C and D. Which one of them is correct? Okay, so here four diagrams are given known as A, B, C, D. That means four slabs are given, rectangular slab. Okay, and this is what first slab, and the ray of light simply traveling like this. Okay, and this is the figure A. Second figure, there okay, this is the another figure. This is A, this is B. Okay, then last option, C is given. Like this, and last option is given okay. So this is the last option. Which option is the correct option, they are asking. We did this yesterday. This is nothing but what? Refraction through the glass slab. Okay, option B is the correct option. How the option B is correct? Wherever there is an incident, then draw the normal. So the ray of light is traveling from rarer to denser, so it bends towards the normal, and when it strikes over here, then again draw normal. So this is a refraction takes place. The ray of light is traveling from denser to rarer, so it is move away. So this is nothing but what your option B. Okay, in this case the ray of light is entering without any refraction, it is coming out. So here what, there is a no refraction takes place here, and here this refraction is not possible. So option B is the correct option over here. Getting this kind of questions, take a screenshot or you can draw the diagram. Okay, write down next question. Next question you can write down. If a man's face is 25 centimeter, if a man's face is 25 centimeter in front of concave shaving mirror, if a man's face is 25 centimeter in front of concave shaving mirror producing erect image 1.5 times the size of the face, 1.5 times the size of the face, comma focal length of the mirror would be, focal length of the mirror would be, first option 75 centimeter, second option 25 centimeter, third option 15 centimeter, last option 60 centimeter, last option 60 centimeter. I'll repeat this. If a man's face is 25 centimeter in front of concave shaving mirror producing erect image 1.5 times the size of the face, focal length of the mirror would be first 75 centimeter, B 25 centimeter, C 15 centimeter and D 60 centimeter. Okay, so these are the options. So here 25 centimeter in front of the concave shaving. Okay, concave mirror is given. Okay, concave mirror, shaving mirror is there. That means image is virtual, erect and a large size image we are getting. That is behind the mirror we are getting. Okay, this is very important for a mirror. So here what? Concave shaving mirror is there. That means image is formed virtual, erect, large size image we are getting, which is behind the mirror. Okay, so what they are saying here, producing an erect image 1.5 times of the size of the face. Okay, that means here magnification M is given 1.5. Okay, तो देखो हाँ, here what they are asking, focal length. They are asking the question for focal length. So very important question. So try to find out the given quantities. 1.5 times of the, what they are saying, 1.5 times of the size of the face. That means here magnification M is given 1.5. Okay, magnification is 1.5 here. So we can write in magnification mirrors minus V by U. Okay, so this is 1.5 is V gave, V is not given, but U is given. No, the man's face is 25 centimeter in front of the concave mirror. तो concave mirror है, तो we are keeping to this side. Okay, so this is concave mirror. So object is in front of the mirror. So U is negative here, minus V, and U I have minus how much? 25. So I have minus 25. This minus minus get cancelled. V is nothing but 1.5 into 25. So V I will get it as a 75 by 2. Okay, or we can write it as, yeah, we will get 75 by 2 centimeter is the answer. Okay, so remove the decimal, that would be easy. 15 by 10. Okay, and then you can find out, you will get answer V is equal to 75 by 2. So if you want, I will show you 15 by 10 into 25. So 5 2s are 10, 5 3s are 15, 25 into 3 75 by 2. Okay, so here we can, they are asking here focal length. Okay, so focal length is nothing but what in case of mirror, 1 by F is equal to 1 by U plus 1 by V. So 1 by U I have as a plus, I have minus 25, and V I got it as a 75 by 2. So minus 25 minus plus 75 by 2. Okay, so do this calculation and check how much is the answer. 70, V is not 75 by 2, 1 upon 75 by 2, that is nothing but 2 by 75. Okay, so here do the, I'll take LCM, minus 3 plus 2 by 75, that is minus 1 by 75. So focal length I am getting minus 75 centimeter. So option, which option? Yeah, option first, minus 75. That is focal length of the concave mirror is minus minus 75. Option A is the correct option over here. getting this? Can you all getting? Or all are sleeping? Hruday, Advait? You are there. Advait, sleeping? Advait, are you there? Only S, correct. Okay. Write down next question. An object at a distance of 30 centimeter. An object at a distance of 30 centimeter from a concave mirror gets its image at the same point at the same point full stop. The focal length of the mirror is the focal length of the mirror is option first minus 30 centimeter, B 30 centimeter, C minus 15 centimeter, and last plus 15 centimeter. Last, that is plus 15 centimeter. Okay. So here an object at a distance of 30 centimeter from the concave mirror and its image at the same point. Okay. The focal length of the mirror is, तो concave mirror है, थोड़ा सा दिमाग लगाओ. Okay, this kind of questions are very important. These kind of questions are making our concepts clear. Concave mirror है. Okay, so here what we have a concave mirror. So here they are saying the object is kept at the focus. Is it focus or what they are saying? The distance 30 centimeter of the concave mirror. Okay. So here object is somewhere kept over here, and that from pole to this distance is 30 centimeter. Image is also formed here only. Okay, V and U are at the same place here. Okay, and that is minus 30 centimeter. Okay, and in this case they are asking the focal length of the mirror. Getting the question? Object and image are formed on this, means image is formed on the same point of that object. Okay, so whenever the object they are asking focal length here, my aim is to find out the focal length. So focal length can you find out here? So you will get 1 by f is nothing but 1 by u plus 1 by v by using mirror formula. So here 1 by minus 30 plus 1 by minus 30. So both are on the same side and at the same point they both are formed. So we can write here minus 2 by 30, that is minus 1 by 15. So focal length is nothing but what? Minus 15 centimeter. So check which option is correct here. C. C is the correct option over here. We'll get the C is the correct option. Okay. So now write down next question. Write down next question. A spherical mirror produces an image of magnification minus 1 A spherical mirror produces an image of magnification minus 1 on the screen placed at a distance of 15 centimeter from the mirror. First, write the type of mirror. First bit, write the type of mirror. Second, find the distance of the image from the object. Find the distance of the image from the object. Last bit, what is the focal length? What is the focal length of the mirror? What is the focal length of the mirror? So I will repeat this. A spherical mirror produces an image of magnification minus 1 on a screen placed at a distance of 50 centimeter from the mirror. First, write the type of mirror. Second, find the distance of the image from the object. See what is the focal length of the mirror. Okay. So here magnification is given. Okay. And as this is a mirror. Okay. So magnification is mentioned over here and that magnification is minus 1. Okay. Here people are where they are making mistake. We know that magnification in any spherical mirror minus V by U. So we are writing this minus of minus 1. Here not required. Actually magnification only given minus 1. Okay, so minus 1 is equal to minus V by U. So I substituted value over here. So now this and this sign is get cancelled and in this case you will get V and U distances are same. Can you get it? Okay, and they are saying the screen is placed at a distance of 50 centimeter from the mirror. Okay, so mirror से 50 सेंटीमीटर पे क्या रखा है? Screen is kept. So here you will get U as what here 50 centimeter. Okay, U we are getting 50 centimeter but in front of the mirror, so it is minus. So U 50 है, तो V is also minus 50 only, no? Because we proved here U and V distances are same. So here first we got. No, they are asking first question, write the type of the mirror. As magnification is negative, so image formed is real. Always remember, whenever the magnification is negative, then image is what formed is real. And in that case, we can say that it is a concave mirror. It's very important. It's a concave mirror. Okay. So you will get UV as a minus 50 and then they are asking what? Find the distance of the image from the object. Okay. So image and object u and v I got. Distance of the image from the object they are asking. So in that case we can write u plus v, that is we are not taking distances while adding as a negative, we are taking modulus. So mod if you are taking, then this negative will become what? Positive. 50 plus 50, that is equal to 100 centimeter. This is the distance. Okay, now they are asking the value for focal length. So use a mirror formula. 1 by f is equal to 1 by u plus 1 by v. So minus 1 by 25, not 25, 50. Minus 50 upon minus 1 by 50, because plus minus will become minus. So minus 2 by 50, that is equal to minus 1 by 25, and focal length you will get it as what? Minus 25 centimeter. Getting this? If this kind of questions are there, so you have to solve it like this. Getting these questions? Okay, so I will end this session today. So we'll continue afterwards. Okay, I'll end this session.